in which case first is more stable than second. Consider our first one here. We have C double bond C, and on this carbon we have an odd electron. So we can recognize that these are free radicals. Free radicals do not have a plus or a minus charge, and hence we cannot explain its stability by using inductive effect, either plus I or minus I. So we should be using either mesomeric effect or hyperconjugation effect to explain the stability of free radicals. Now according to that, we know that if there is an C double bond C and next to that we have a carbon with odd electron, then these pi electrons do move towards the free radical, stabilizing it. Therefore, this type of system called as allyl free radical is quite stable. So we should watch out for this system. Then we also know that tertiary free radical is having more number of hyperconjugation forms, alpha hydrogen, and therefore it is more stable than secondary, more stable than primary free radical. We should also consider the extra stability associated with benzyl free radical, which looks like this. This is primary benzyl. If we go on substituting these two hydrogens also by phenyl rings, then we get tertiary benzyl. This tertiary benzyl free radical is extremely stable. Considering all these, let's get back to our question. In the option A, we can see that C double bond C and the odd electron are there on the same carbon, because of which no resonance is possible. In the second option, we can see we have allyl system, C double bond C, and the carbon with odd electron is on the next carbon. So therefore, plus M effect is possible here, and hence the second one is more stable than first one. In B, we can see that this carbon with the odd electron is secondary. It's attached to 2 carbons, whereas this carbon is attached to 3 carbons, tertiary. So tertiary is more stable than secondary. We can also explain this by counting the alpha hydrogen. Here we have CH2, here also we have CH2. So we have 4 alpha hydrogens, whereas here we have CH2, CH2, and here we have CH3. So we have 7 alpha hydrogens. This is also the reason why second one is more stable than first. That's why we conclude that tertiary is more stable than secondary than primary. Coming to option C, we cannot explain this by any of these 3 effects, but in general a cyclopropyl free radical is much more unstable than a cyclohexyl free radical. So the cyclohexyl free radical is associated with more stability. This is due to the arrangement, stereochemistry. Coming to the last one here, option D. This is pH, indicates phenyl, so C6H5. So this system actually looks like our third system. It is called as tertiary benzyl. Tertiary benzyl is much more stable than tertiary alkyl. So this is a normally tertiary free radical, but this one is tertiary benzyl. More resonance, more hyperconjugation forms are possible in tertiary benzyl, and hence it's more stable. Question says in which case first is more stable than second. So our answer will be option D.